So in this lesson, we will start to learn new database concept, normalization. What is the aim of the normalization? We are going to use normalization. This point very important because up to now, we have worked with single table. In our database design, we have worked only with single table. But after starting from this lesson, we will start to work with many tables. In our database system, we will have more, instead of one single table, we will have more tables. That's why if you want to understand when you need second and third table, how can you divide your one single table into the many small tables, you should understand what is normalization and then what is the use of the normalization, aim of the normalization. If you can understand what is normalization, you can understand how to divide your single table into the many small tables. So normalization is a process to organize your data in an efficient way. If you want to organize your data in an efficient way by the means of the storage place, you need to normalize your data. So actually it is a one terminologic word. Yes, you should understand, instead of what is normalization, you should understand its terminologic meaning. You should understand terminologic meaning. Also, there is one terminology meaning: normal form 1, normal form 2, normal form 3. You can think this normal form is a step 1. For example, if I will tell you normal form 1, you can understand first step in the normalization. If we tell second normal form, you can think it is a second step in the normalization, third step in the normalization. Actually, we have several normalization steps, but common practice, database designer, usually they are not using all these steps. They are using sometimes 2, sometimes 3, sometimes 3.5 and 4 steps they are using. Because when you are normal, also in the, like indexing, using index or not using index, there is a trade-off. Like that, using normalization, to normalize your database too much or to not normalize your database, there is a trade-off. If you normalize your database too much, this means your database design will be very complex. But if you not use any normalization, this means you will use too much, you will waste too much disk space in the computer system. That's why you should decide how much amount of normalization you will do. Normally, we are going to do 1, 2, and third step. First, second, and third step, we are going to normalize your database. So it helps us to control redundancy. What is the redundancy? I will explain much later. For example, each data item stored in a database should be stored in one place. For example, look at this example. For example, I have 5 tables in my database. 5 tables. Ahmet, Pasha, Antalya, and Turkey should be stored in one place in my database system. What does it mean? For example, let's add one more column here, department. And department location. For example, this student going to do computer engineering department. Computer engineering department. And it is inside the B block, for example. B block. Location is a B block. For example, this student going to medicine. And he is in the D block, for example. Again, this student going to computer engineering and B block. And this one also computer engineering, B block. This one, medicine, D block. Look at it now. Computer engineering and B block, one time here. Also here, computer engineering again, B block, repeated. Medicine, and also repeated here. Think you have not like that 5 records. Think you have like that 1,000 records. 1,000 records. This method is not efficient, yes, to use one single table. If you use like that one single table to keep records of all these this data about the student, it is not efficient because I am wasting my space. Instead of saving this information, computer engineering and B block 1 times, I am using it 1, 2, 3 times. And I am losing many space. But if I will divide it, this one cut from here, cut and right here. Now I have 2 tables. This table, it is one of my table. This is another table. Yes. What can you do? You can write here department ID. ID. Second table. This is, for example, first department. This is a second department. Yes. Now, you don't need these places now. For now, let me make them red. I will delete this part, yes. Only you need to add something here. Yes, for example, here, you can tell department ID. For example, this Ahmed going to do computer engineering, 1. 1 means in this table, computer engineering. Remzi also going to do medicine. Department of medicine is a 2. Dastan going to do computer engineering. ID is 1. Selim going to do computer engineering. Its ID is 1. Dastan Bek going to do medicine. 2. Now I can delete this part. I don't need this section. Yes. Instead of deleting, let me take this part to do cut. Now look at only repeating part is this one. 1, 1, 1. But here, if I will use this approach, repeating one is a computer engineering B block, computer engineering B block, computer engineering B block. Here, repeating only 2, 2. Small, yes. But here, medicine D block, medicine D block. Now I have 2 tables. First table, this one. Second table, this one. Here, when you look at here, computer engineering recorded in this table only 1 time. Medicine recorded only 1 time. B block recorded 1 time. This means data we told, look at this one. In the database approach, ideally, it is wanted like that, yes? Each data item is stored in only 1 place in the database. This means you should store 1 piece of data in database system 1 time, like that. Yes, we are storing computer engineering 1 time, not in the previous option. We store it 1, 2, 3 times. Medicine, in the previous option, we have stored it 1, 2 times. But now, medicine and D block in this database system stored in 1 place, 1 time. 1 place, 1 time. That's why normalization will increase control to data redundancy. And it will increase your data optimization by means of the using storage space. So what is the first normalization? How can you make normalization now? If you understand what is the aim of the normalization? This means you should, if you have one big, large table, you should normalize it if it is possible. When you are normalizing, what you should do? First things you should think. First normalization form definition is like that. Each column should contain atomic value. This means in every column you should have one piece of the information. If you look at this table, for example, what is wrong with it? You can see easily inside this column there is a two piece of information: name of the student and surname of the student. This means that violating this first normal form definition. This means this form is this table is not in the form of the first normalization. Yes, it is unnormalized table. How can you make correction? Instead of using one column here, you can use two columns, first name column and last name column. If instead of designing your table like that, if you design like that, this is a good design. This means it will meet the rules of the first normalization form. This table is first in the first normalization form. Look at this is a unnormalized and not good design. If this design like that one table, this means not good in a design. By the means of design perspective, this table is not good, not designed well. Because we told each column should contain atomic information. Atomic means, this means in one column you should have one piece of information. Here we have two pieces of information, name and surname together staying in this place. Second rule, there should not be repeating columns, repeating groups of the columns. For example, if you look at this example, let's look at this example. Look at here. Hobby 1, hobby 2, hobby 3. Look at repeating what we told. There should not be repeating groups of column. Hobby 1, hobby 2, hobby 3. They are all related to the one student. Repeating groups. Who is repeating here? Hobby column repeating. Hobby 1, hobby 2, hobby 3. Hobby 2, hobby 3. Here, if you put all this information into the same place, it is also violating first rule. Each column should contain atomic value. Yes. Now look at here. This is also not good design. If you make one column, and if you put, for example, Ahmed has two hobby, football and programming. Ramzi, 3 hobby, reading, travel, running. It is not good because we told in one column you should keep one piece of information. But here there is two pieces of information. Here there is a 3 pieces of different information. But if you divide this one in this approach like that, for example, we have normalized this table like that. We divided it to the first name and last name. Here it is a solution, but in this place it is not solution. If you divided this one, hobby 1, hobby 2, hobby 3, it is not solution here. Because this time it is violating the second rule. Second rule is telling you should not have repeating groups of the columns. You should not have like that columns. Yes, this is also not normalized. Yes, this table is unnormalized. This one also unnormalized. This is a wrong design. What is the solution of this one? We should do another table. Yes, if we want to keep hobby information of the students, we should not keep this information in the same table. We should keep these hobbies in the second table. Let's do. This is the one solution. Look at now. We have this part. This part will stay in the first table. This part will stay in the first table. These hobbies will go to second table. Yes. Till first name to birth date, it will stay in this table. Hobbies will go to the second table. It is a partial solution. It is not perfect solution, but better than this and this solution. This one at all not acceptable. This one also at all not acceptable. But this one partially acceptable. What is wrong with this one? Who can tell? Do you have an idea what is wrong with this one?
They are repeating and
Yes,
they're wasting.
yes, they are repeating. Yes, this solution is a better than these repeating columns and this atomic containing more values in one column, better than this one. But also this is not final solution. We should improve this design more. How? Because as your friend told, there is some information repeating. But look at football, repeat 1, 2 times. Programming 1 times. Reading, for example, 1, 2, 3 times, 4 times. Yes, it is not good solution, but we told this is better than this one and this one. So this is a unnormalized. Why? Because in this column there is a 2 piece of information, unnormalized. But this table is a normalized, but in the first normal form. What is its form? Its form is a first normal form. Yes. This table is a unnormalized. Unnormalized. Because this column contains much information. This table also unnormalized. Unnormalized. But it is in first normal form, not in first unnormalized at all, because it is a repeating columns. Look at unnormalized. This table is a nothing wrong with for now. For now, there is nothing wrong with it. This why it is a first normal form. First normal form. This one also not good, but partially good solution. But it is we can tell this table in the form of the first normal form. Because what is the rule of the first normal form? Let's remind. Each column should contain single value, single data, piece of the data. And there should not be a repeating column. Yes. There is a repeating row, but there is no repeating column. That's why it is a in first normal form. Yes. It is in the form of the first normal form. This table is in the form of the first normal form. For now, it is okay. Let's go to second normal form. What are the rules for second normal form? When you look at one table, if you want to tell this table is in the second normal form or not, it should have all requirements of the first normal form. Yes. If you want to know this table in the second normal form or not, its first rule, it should meet or it should provide the all requirements of the first normal form. First normal form requirement, there was 2. One of them in one column should be one piece of information. Let's look at this one. Yes. Only names, only genders, only salaries, only department head, only location. It is okay. Yes. Also, first normal form is telling there's no repeating group of the column. None of the column repeating. For example, there is no department location 1, department location 2. There is no like that column. It's in the first normal form. In that case, you should look at the second normal form rule. Second normal form rules, first one of this one. It is telling non-key columns are dependent on the table primary key. This is important. Let's look at more close. What does it mean? Non-key columns are dependent on the primary table primary key. Look at here. This is a key column. We know this is a primary key column. Yes. This is a not key column. This is a ordinary column. Name column. This is not key. This is not key. Not key. This is a not key. Only we have one primary key here. Key. They are not key columns. Non-key columns. They are non-key columns. This means it is telling non-key columns. This means this one, this one, this one, this one, this one, this one should depend on this one. What does it mean? For example, if this is an employee, this name, whose name this one? Employee's name. This means this name depending to the primary key. Yes. This primary key is employee key. Yes. Employee, whose key this one? Employee key. This gender, whose this gender? Employee gender. It is dependent this one. Whose salary this one? Whose salary this one? Employees salary. Whose department this one? Employees department. Yes. Who's this head? Who's this head? It looks. This is important. You should understand this place. Who's this head? Who's the head of the department? John. It is dependent to the department or dependent to the student. This head of the department person, this person is not dependent on the employee. It is dependent on the department. Yes, because if department change, head of department should change. Where is this location? Department location is not dependent on the employee, because this location is not employee's location. Yes, this location is not employee's location. This location is a department location. Yes, this means there is something here. Yes, we should care. Third rule, there is no redundancy of data. This means all data is stored in one place. Look at here, you can see easily John, IT, John, London, IT, John, London, IT, John, London, stored in this table in three different places. This means there is a redundancy here. There is a data redundancy in this section. IT, John, London. IT, John, London. IT, John, London. It is a data redundancy. This piece of information, all these three of them stored 3 times. Yes, I hope you understand. How can you make correction here? This means this table is not in the second normal form, but it is in the first normal form. This table is in the first normal form. If you want to make it second normal form, you should divide this part to the another table. For example, we can do from this place department table, ID, department name, department head, department location. After that, this information can stay till this place in the first table. But if you want to make connection, we are not interested how to make connection for now. Later we will see how to make relationship between tables. Our aim in this lesson to understand how to divide our table into the more pieces. Yes. And if you want to connect, you should add department ID here, and then you can write, for example, this employee from the IT department. The ID of the IT is 1. Just write there 1. This employee is from the human resource. Here, HR. And in this table, HR is a ID of the 2. That's why I write there 2. Yes. Now we have 2 tables. Look at here. How many pieces information you have? 1. Repeating 1, 2, 3. 1, 2, 3, 1, 2, 3. This information repeated 2 times. How many times? 1, 2, 3, 4, 5, 6 cells of the information. You just waste your space. But here we have entered this data, IT, John, and London, to the table only 1 time. So this table is in the first normal form, but it is not in the second normal form because there is non-key columns. There is some non-key columns. They are not dependent on the table ID. Table ID here. Yes. Location is not dependent. This location is not dependent on the employee. Yes. Employee. Dependent location is dependent on the department. This ID, right? London department location is dependent on this department ID. Second table. So also you should check there should be no data redundancy. This means data should store in one place only. You should store your table in one space in this example, let's look at. We told this example. This is a partial. We told this is a partial solution. Yes. If you look at this one, is in the first normal form. Yes. Also, we can tell now it is also in the second normal form. Yes. Because there is no, for example, let's check this table is a first normal form or second normal form. If it is first normal form, every column should contain one piece of information. Yes, first name, only there is a first names here. Only there is a last names, only one city, only one country, only one birth date. Yes, there is no repeating columns here. For example, hobby 1, hobby 2, hobby 3. There is no birthday 1, birthday 3, because one student also cannot have many birthdays. Yes. Ahmet also from one country. He cannot be from the several countries. Yes, he cannot be from the several countries. This is in the second normal form. In the second normal form. Why? Because when you look at, for example, first name, you should check all non-key fields. We have 1, 2, 3, 4, 5 non-key column here. Let's look at the first name. First name is a name of the student. Yes, these names, last name of this student, STD student. These locations, city and countries, they are all locations of the student. These birthday of the student. Yes, all these columns depending on this one. There is no also repeating information here. That's why we can tell it's in the second normal form. But when you look at here, there is a football, programming, reading, there is some repeating. This is not in the second normal form. Actually, you can divide this table into the one more table, location table, location tables. Yes, this is because this Erbil, Iraq repeating here, location tables. Yes, it is not in the second normal form. This is also not in the second normal form because there is some repeating rows. Yes. Now look at this one. What is the solution of this one? What is the solution of this one? How can we solve this table? There is some repeating part. Look at football, programming, reading, travel, running, create, karate, football, reading, travel, reading. Yes. Instead of this one, we can do like that. Look at this table. This table is when you look at, there is no repeating. Football, only one time. Programming, one time. Reading, one time. This is a hobbies table. This is a student table. First name, last name, and is location. When after that you should connect and you should link this table and this table to each other. How can we connect this one? We will link them by using this link table. In this link table, for example, hobbies 1, football. Whose hobbies? Student ID. Ahmet's hobbies. Second hobby, programming. Hobbies of the Ahmet also. This means Ahmet, number 1 is Ahmet here. Ahmet has hobby of 1, football, and second hobby, programming. Second student, Ramzi, has hobby of the 3, reading, 4, traveling, 5, running. Ahmet has, Ramzi has 3 hobby. This part, it is not today's subject. Don't worry about it. Yes, only you should understand how can you normalize this table to get rid of the data redundancy. Now we have 2 tables. There is nothing repeating here. If you want to, you can normalize one more time this one. You can also divide it students and locations or address table. Yes. Here you can divide them one more table here. We thought it is a normalization. If you normalize every single tables, it will be more complex. Before, look at now. Before, we have only one table. Look at simple. Or this table, also this simple design. Yes. But this table and this table at all, they are not good design. But finally, we have these 3 tables, 1, 2, 3. It is more complex now. Yes. Also, you should make relationship between them. How to make relationship all of them, a little bit headache, more complex. When you normalizing your database, you are working with complex system. When you are not normalizing your database, you are working with simple design. Yes, it is a trade-off. You want to work with complex database system, or you want to work with simple system. But if you are using simple system like that, simple database system, this means you are wasting too many spaces. Look at this one, repeating. All this one, how many? Look at how many places only to keep hobbies you have used. These all spaces you have used to keep the record of hobbies. But in this design, only you have used these spaces, small spaces you have used. But for this, only for 6 student thing, you have 1,000 student, 1,000 student. If you have 1,000 student or million records here, how much amount of the space you will gain? Yes. Look at this table now. Students and their projects. So you can see this it is matching the first normal form rules. Yes, what was the first normal forms? In one column, there should be one information. Or in this column, there is only names. In this column, only last name, only these locations. Yes, only these birth dates, and only project codes here, only project names. And then also there is no repeating columns like hobby 1, hobby 2, hobby 3. There's no repeating column here. It's fitting the first normal form, but it is not fitting the second normal form because, for example, this column project name is not dependent on the student. This project name dependent on the project code. Yes, this is a not name of the any student. This is the name of the project. Yes, but this name, first name and last name, they are the name of this student. That's why they are dependent on this student ID. But this project name is not name of this student. Yes, it is the name of this project. Of course, also keep in your mind, this table is just demonstration table. That's why they are in the small size. Yes, For example, in one student, you may have many other fields here. For example, father's name, mother's name, email address, telephone numbers. You can have many more information about student. Also, you can have many information about the project. For example, project starting date, project end date, project financial condition, project place, project budget. You can have also many field more. You can add, yes. In that case, you cannot imagine how much amount the space you are wasting, yes, because there will be many space you are wasting always. They are just some part of the tables we have here. Yes. How can you solve this problem now? Obviously, you can see this is this field dependent on this ID. That's why they can stay in one table. But this project name, and if there is a coming names, coming columns, for example, project starting date, project ending date, project budget, something, that column, together with this one, these ones will go to the second table. Yes. If you want to connect this table and this table to each other, you should bring student ID from here to here, and then you should write here. For example, this project is taken by this ID number 1, Ahmed. This project taken by Mustafa. This one. Yes. Second normal form. So what is the third normal form? If one table in the third normal form, this means it should meet all requirements of the second normal form. Yes, what is the second normal form requirement? All non-key columns should depend on the table ID. And also there is no repeat of the data. Yes, this is also this, if one table is in the form of the second form, it should form of the in the first normal form. Yes. All this one, this means if one table in the third normal form, it should have all requirements of the first and second normal form. Yes. All, apart from this one, also it should not have any transitive dependencies. What is transitive dependencies? For example, here there is a st and zip. There is a these two column has a transitive dependencies. Transitive dependencies. What does it mean? What is zip code? I hope you know zip code. Zip code is every city on the world there is a one zip code. Yes. For example, you can check what is zip code of the Antalya. This is not this one. This one. First one. This one. Istanbul is this one. What about Bishkek? Look at now this column and this column, they have transitive dependency. What does it mean? If you change Antalya, also you should change this one. For example, think Ahmet move from Antalya to Istanbul. Istanbul. Yes, Ahmet told, for example, Ahmet came to us. Before Ahmet, before Ahmet was from Antalya, and he told us he changed his address, and we are updating his information. For example, instead of Antalya, we are writing here Istanbul. This correction is correct? No, this correction is not correct because this zip code field also dependent on the state. That's why also we should change this code. Yes, if you live like that, it's wrong. Yes, you'll make mistake. If you make like the change, you will make mistake. That's why you should change also this one. Yes, this is. For example, if Selim move from Istanbul to Bishkek, copy, and when you change this place, Bishkek. This correction is enough? No. Also, you should go and you should change the zip code. What is the problem here? This means when you are updating, when you update one field, you can make mistake. Yes, because when you update one transitive field, you may make mistake because to updating this field itself, it's not enough. Also, you should update at the same time this place. But it is not good design because you may not know also to change this information. Yes, there are the transitive information. This means if you want to make change in one database system in one place, it should be enough. You should not go and you should not find the dependent columns, and you should not also update that once. Yes, if you want to change one piece of information in one database, when you change that cell, it should be enough. You should not check by yourself if there is any dependent columns to this one. Let me find also them and let me make correction on that one. Yes, when you are changing one piece of information, it should be enough. How can you make this one? You can do like that. For example, you can divide this table. This table has 1, 2, 3, 4 columns into the 2 table. For example, student ID, student name, and zip can be one table. Zip and stick can be another table. Let's make like that design. Student name, last name, and zip will stay in the same table, but these 2 of them will go to another table. Copy, paste here. And we will delete this part. Okay, from here, we are taking this part. Delete. And here also, we can ID field. 1, we don't need this field. 2.
Mister, what about the country?
Country is a different. Yes, we can also take country from there. I will come to that point. Also, we don't need this one for now. Yes. Also, we can take country from here. But country is a different issue. Just we will deal with this one, okay? Okay, let's take also country from here. Now this one is a zip code, this one, yes? This zip code, this one, zip code, this one. For example, now if you want to change one information, for example, Ahmet move from Bishkek to the Antalya. What we will do? Bishkek to Istanbul, for example. Bishkek to Istanbul, Ahmet. Ahmet now in the Istanbul to Bishkek. Instead of just, I am writing here, from here, copy, and just changing here. Ahmet move from Istanbul to Bishkek. What I will do, I will change this one. Yes, now it's correct. Ahmet move now to the Istanbul. Not Istanbul, to Bishkek. Now Ahmet living in the Bishkek. Here I don't need to change anything. Yes. Now I have 1, 2, 3 table instead of one big table. Yes. Better design. Your friend asked, what about, he told, what about country? Yes. Let's make it better design in that case. What can we do? We can do one more table. This is the address. Let's do table address. For example, here, let's tell first one city, for example, city. City, instead of this one, we will do ID. But let's tell this one not ID, city ID. Let's tell city ID. City ID. Yes, city ID. City ID will come from this table. And country. We are taking here, from here. We don't need here anymore, country. For example, here also we need that address ID. Address ID. Here also address ID. ID. For example, first student we told from the Bishkek. Yes. ID 2. Is the first address 1. Country is a, for example, Turkey. 2, Kırgızistan. Also, you can add, for example, phone number here. Email. You can add more information about address. And then home address, for example, you can add here. Home address. how much you want, you can add. You can add many things here. What about address ID is a 1 here, because it's a first address. Whose address is on? 1, first address. Ahmet from Bishkek. Yes. 2. City address. If you want to know what is 2, you should come to this table and you should understand this is a Bishkek zip code. Phone number can be entered. Second student, Remzi. Remzi from Istanbul. This is a second address in this table. City, Remzi from this zip code. This zip code is a Istanbul. Istanbul ID 1. This is a country, Turkey. And you can enter this place like that. This is a 2. You can have now many 1, 2, 3 tables. But this third normal form is not used too much. Yes, you should not try to use this one. In some cases, you can use. Yes, we are actually we are going to normalize. There are 7 normalization steps. There are 7 normalization steps. First and second normalization is enough. You don't need to try to also normalize this form. Yes, there are also another consideration. Look at, for example, here, country consideration came out. Yes, but if you want to do, you can do. You are free. But normally, it is enough to normalize first in the first normal form, and in the second normal form is quite enough for the normalization. First and second normalization in one database design, it is quite enough. Okay. So why you need to normalize? Let's remind and let's look at more close. We have to normalize our database design. We have 4 aims. One of them, arranging data into 2 logical grouping such that each group describes a small part of the whole. Yes, we are arranging our data into 2 small groups. Yes, every group describes small part of the whole. For example, in this part, we have, for example, this group describing student information related to student. This group of information describing us information related to the project. Yes, we told, for example, you can add more field here. Project start date, project end date, project due date, project budget. Yes, project aim, project related to project. You can add many fields. And now you have logically 2 groups. One group of information related to project, other group of the data information related to the student. Here also you can add more information. For example, student father name, father's name, student mother's name, student address, student email address, student phone number. You can add many information, but all this information related to the student. We are calling them entity. First entity about student, second entity is about project. Yes, we can do like that, logical groups. Minimizing the amount of the duplicate data stored in database. We give this information too much. Yes. For example, in this one, we have duplicate information. IT John London, IT John London, IT John London. We have duplicate information. We can minimize duplicate information. Yes, when you normalize, you can duplicate this one. What can you do? You can divide this data into the 2 logical groups. One logical group about department, another logical group about employee. This means in this design we have 2 entities. Entity 1 related to the department entity to related to the our second entity is a employee here, employee table. First entity, our first entity is a department, second entity is a employees. Third one is organizing data such that when you modify it, you make the change in one place. Yes, we have explained this one. For example, when you are changing state, it is not enough. Also, you should change it to the here. Also, in this design, for example, Sam transfer from IT department to the human resource department. Yes, human resource department. What will you do in that case? For example, if you write here human resource, for example, keep in your mind, be careful. For example, Sam transferred from IT department to the human resource department. If you update only this place, it is enough? No. Because if you write here only, if you delete IT and if you write here human resource, it will be right. It will be wrong here. Because also, if you change this one, also you should update this department head. Anymore, John is not head of the Sam. Who's Mike? Mike is that's why you should, Mike, head of the new head of the Sam. That's why you should also update this one. Also, since Sam is transferred to the human resource, also his location change. Yes, Sam is not working anymore in London. He should work in the Sydney. Also, you should, when you update this field, it is not enough in this design. Also, you should update here. Also, you should update here. But in this design, if you design your database like that, what will you do? Only you will change this place. Department ID 1, you will delete this one, and you write here 2. And you don't need to make change anymore in this table. Yes, in this design. It is enough here. If you make one change here, it is enough. But if you design your table database like that, if you change something here, also you should change this one or that one. You should make 3 different change in 3 different locations in database. But here, for example, if Sam transfer from human resource IT to the human resource, just you are writing here 2. This is enough. One change, it is enough to make. So last aim to make normalization, making a database in which you can access and manipulate data quickly and efficiently without compromising integrity of the data in storage. Yes, they are the same things. Yes, when you access or manipulate data quickly and efficiently without compromising the integrity of data in storage. For example, if in this design, if I would change IT to the human resource, what will happen? If you leave like that without making any more change, this means you will while you will destroy integrity of data. Yes, because if you write here human resource, John is not head of the human resource. London is not the location of the human resource. You have lost integrity of this record. This IT, John and London has an integrity. Yes, they are dependent on each other. All. You'll lose. That's why if you don't want the compromising the integrity of data, when you make one change, also be sure you should make change in this place. Also, you should be sure also make change in this place. But here, if you make change to, that's all. Integrity is still same because 2 means is a department ID. It also 2 means department of the human resource. Also, it means head of the department Mike. Also, location of the department Sydney. This piece of information has a integrity. Still has a integrity. So in some resources you can find this one is a data integrity, referential integrity, key data access. Yes. So we are calling this design as a flat file design. Flat file because it has only one table. Okay. One table, flat file design. It is easy to design. Yes, you don't need to discover which field is, which column is dependent to which table, how I will divide. You don't need to worry about how can you divide these tables into the two or more. Yes, you don't need to discover or do anything. Yes, they are all easy design, flat file design. We are calling this one. But in the second design is a flat file design is a separate sheet form. Yes, you are just like Excel table. In the Excel we have one table. You can write make column, add information, make column, add information, make column, add information. It is easy. If you want to add new information about the student, you can add column and continue. But second design, we didn't. Second design, this design is a relational database design. Relational database design because we have many tables and then they are related to each other. They have link or related to each other. Relational database design. This is a flat file design. Flat file design is a easy, but it is not efficient way to store data and also access data or change data. For example, in this place, it is not. They are telling data integrity, key data access. What does it mean? Key data access. For example, in this design, if IT department had changed from John to, for example, Smith, anymore, John is not head of the IT department. What we need to do, you should delete John from here and you should write it Smith. But it is not enough. To access this John and to change it, not enough. Also, you should come here and you should write here Smith. You should change it also Smith. Yes. When you are accessing, also problem. Yes. When, for example, when you access data to change it, also it is a problem. You should make 1, 2, 3 times change. You should find all Johns from this table and you should change. But here, for example, new head of the IT department is not anymore John. Smith became. You can access one time this location and you can change it. You can delete John from here and you can write there Smith. It is enough. You don't need to make change. For example, this employee is a belong to the one. When you come here, you will see one IT Smith John. It is already changed for him. Yes, when you change here, for all employees, automatically this means you have changed the head. Yes, when you are accessing one record, also it will not be any more problem to you. Key. That's why they are data integrity we told. Referential integrity, we'll explain it later more. Key data access, we give example for it. So